So now we're going to talk about scaling your data. So standardization of data sets is a common requirement for machine learning estimators in sklearn. So we're going to talk about normalization, standardization, and min-max scaling. Okay, so normalizing typically refers to taking your feature matrix and scaling it between 0 and 1. Okay, making sure that everything's in the same units. Standardization deals with standardizing your data using what's called standard normal units. Okay, so basically you're saying the number of standardizations it is from the mean. Fair enough. Min-max scalar is different. You're basically saying I'm going to scale the data between -1 and +1 with a mean of 0. And you could specify these things when you're calling it, when you're calling the particular function. So now let's go ahead and take a look at this. So again, with missing values, there are a number of different ways you can handle it. Before we talked about how to use a fill-in value of 0. That's not always the best way of doing things, or dropping rows. That's definitely not the best way of doing things. But with iterative imputer, essentially what you're doing is you can use k nearest neighbors or a variety of other features in order to impute the missing value. So that's something that's probably a little bit more robust in terms of ways to do that. So if we just go Shift Tab, it's right here, we can see what's here. So we can look at the initial strategy. Nearest neighbor features, we just placed that as 9. Imputation order, you can change that as well. And they have random state. So again, this is just using a nearest neighbors approximation, which is much better than just using the mean or something of that nature. So essentially what you're doing is you're saying, let's look at the entire feature matrix, or let's look at a certain number of the features within the feature matrix and use that to approximate the missing value, right? So that definitely makes a lot of sense to use. So I'd recommend you use that whenever possible. And again, just going through the documentation, it gives you a lot more detail in terms of what's actually being done here. Okay, so let's see if there's yes, so we have lots of documentation that you can look at as well. Let's close that up. All right. And all you have to do is use the typical format of fit transform, and we're just going to transform the entire data set. We're not going to segment it because we're really focused on what it looks like when you're standardizing the data set, and then also taking a look at the correlation matrix. So we need all the data in order to do that. Okay, so we're going to create a data frame here by just simply calling pd.dataframe. All right. And you need to say the index is the data frames index, and then the column names are going to be the data frames columns. That way you can map everything through and understand exactly what you're getting. All right. So here, what you'll see is we have the imputed value. So if there's any missing values, it'll make sure it uses that imputation technique here, so you can see what's there. And here what we're going to do is we are going to normalize the feature set. So that's going to help us really understand what normalization looks like. And it's just going to place everything between 0 and 1. Okay. So we call normalize, and just to make sure we understand what that does, documentation, displays everything in its unit norm. And there's really nothing you have to do. All you have to do is just call it. There are other parameters you could put in. So if you want to, you could use L1 or L2 normalization. That kind of goes beyond the scope of what we're looking at here. There is an example here as well. And there we go. But what we want to do now is take a look at what the values look like. So when we call head, you can see that everything is placed between 0 and 1. And that's essentially what this does. All right. So actually, we can expand it a little bit. Let's Go to 5. See? So now you can see all the different values, and we really understand what's there. All right. So now we're going to take a look at the correlation. Before, when we looked at it, we were able to see that the correlation between oil and the trade weighted dollar was about -76. Now we see that after the feature set has been normalized, it's very high. It's 0.99. And this holds up in a variety of different time periods as well. So feel free to explore the data set on your own. But that's astonishing. So, and what you'll also see is the value of crude oil production for Venezuela as well as Saudi Arabia is much lower. So normalizing definitely has an effect, and you should definitely take a look at that. Now, what's interesting is that the yield curve, 5-year, 7-year, 10-year, 20-year, 30-year, they're all pretty much the same as what we saw before. And that makes sense because, again, they're all within the same distribution. They all come from a very similar distribution. So again, you're looking at data that's going to be between 0 and 1 anyway. So for the most part, I mean, sometimes you're going to see a little bit higher than that, but over the last 10 years, it's going to be between 0 and 1. So that's why the correlations hold up. But this is something that's really interesting. So when you normalize the data, you're getting this type of correlation. And we're just looking at the correlation matrix, and you can compare it to what we had before. So going here, you can see that the correlation for Brent is 0.99 versus the trade weighted dollar. Very interesting. And you can continue to go further down, see the relationships between Brent and the other factors that we talked about, the domestic yield curve. So one of the things you might want to look at is not just the Treasury yield curve. You might want to take a look at the Eurozone, look at policy there in terms of rate setting and things of that nature. So something to take a look at. Beautiful graph, easy to use with Seaborn. And what we're going to do now is we're going to take a look at standard scalar and go through a very similar format. Okay, so here we have standard scalar. Let's instantiate that. And what you do is you click on fit transform and follow the same process in terms of looking at the scale data, excuse me. You want to make sure that your columns refer to the original data frame columns. All right, so to do that, we can always just look at the documentation yet again, so you understand exactly where everything goes. That's just Shift Tab. All right, and there might be an example here as well. So let's just double check, see what that looks like. There should be an example. If there isn't, I'm giving you one. So yes, there we go. Okay, so here's the example on constructing a data frame from a dictionary. Very simple to do. All right, so with that, let's go ahead and take a look at this annotation. So here's the interesting takeaway. So just by changing the way that we scale it, if we look at using a standardization instead of normalization, what you'll find is the correlation drops dramatically. So it was 0.99 and now it's 0.76. So it makes a difference. It definitely makes a difference. So the way that you standardize it, if you scale the data between 0 and 1, or you look at standard normal units, that has an impact on your analysis, and you have to do some due diligence to understand which is appropriate. Fair enough. Okay, so let's take a quick pause, and we're going to look at a few other methods and then close out pre-processing.